Okay. Now, next one here. So, this one here isn't so bad. It's a bit more straightforward. Diagram below shows a battery of 1.5 volts and internal resistance R connected in series with a 6 ohm resistor. So the first one, explain, it's not drawn on the diagram, but there's a voltmeter across the top there, so I'll draw that in. And then there's a voltmeter here. Now somebody tell me, when I close the switch here, why does the voltmeter decrease the reading? Anybody?
Because it opens a current that way, doesn't it?
Yeah.
So instead of originally where it would be running through only the voltmeter, then it would have to split. And
basically it. Originally when the switch is open, the only resistance in the circuit is R. But when the switch is closed, the resistance in the circuit is now 6 and R. So as you know, when you increase the resistance, what happens to the voltage? It drops. Yes, decreases. Okay?
If the resistance increases, doesn't mean that the current will decrease and the V will stay the same?
Yeah, the total voltage will have to stay the same. But that's where the second part now is the calculation. Okay, so now, if the reading on the voltmeter is 1.4, calculate the resistance here. So we know that this here is 1.4 volts. Now, let me draw the current in. So which way is the current going? Well, it'll be going this way. Okay. What's wrong? You worried about Brendan? We're all worried about him.
no, it's fine.
Okay. Are you making notes? So here it's 1.4. Now how many, and the battery is 1.58. So I don't know, what do you want to use? Do you want to use, I think we can do this just using Ohm's law. So if you were to look from here to here, what's the voltage? It's 1.4. You see, because the voltmeter says it's 1.4 from here to here. Yes?
Yeah.
Are you getting confused? Are you... Curdy, please focus here. Let's use the loop rule. 1.58, start here. Now what happens when I pass through this? Minus I or. Then I go around and then here? Minus I times 6. And then back to the start, so that equals 0. So if you want, you can say 1.58 equals I times 6 plus R. Or if you want, you can say I equals 1.58 over 6 plus R. So we need another equation to solve this. And the other equation comes from looking at this part of the loop. So when you look at the voltmeter, now please be very careful. I almost was going to say from here to here, which is right, but when you really think about it, it's actually from here to here, because the current is going this way around. You see? So that 1.4 is for this part of the journey. So how much voltage is through this part of the journey? 1.4. And what's the resistance for this part of the journey? What is it? 6. So you can use Ohm's law, V equals I or, and you can get the I, or the or, the I here. So the I equals V over 6. And you can put that back in here. So you get 1.4 over 6 equals 1.58 over 6 plus r, and you can solve it. So what's the best way to solve this? Cross multiply, so you get 1.4 times 6 plus r equals 6 times 1.58. So Avenue, what's 6 times 1.58, please?
9.48.
Okay, and then what's 1.4 times 6?
It's 8.4.
8.4. Okay, so to finish now, r equals 9.48 minus 8.4 all over 1.4. So I really hope you're going to say 0.77.
0.771.
Great. And the reason I said I hope you say that is because the question says, show that the r will be 0.77. Isn't it nice when it works out like that? Okay. Next one now, 18.